All right, next we got Charles' law. So Charles' law relates volume and temperature. Again, if you notice, this is based on the combined gas law where we used to have pressure up here. But we're only dealing with volume and temperature, and it assumes that pressure is the same. How you know that you have to use this equation is they will tell you something about volume and something about temperature, but they will not mention pressure at all, or they will say that pressure is constant. Pressure stays the same. So let's start by writing our equation. V1 over T1 is equal to V2 over T2. And next we have to identify our variables. So we got V1, T1, and V2, T2. Let's read the problem. So a gas is held at 120 degrees Celsius in a volume of 13 liters. So right here we got our initial values for volume and temperature. So volume is 13 liters, temperature is 120 degrees Celsius. However, you have to remember that temperature in these problems has to be turned into Kelvin. So degrees Celsius plus 273 is equal to Kelvin. 120 plus 273 is equal to 120 plus 273, 393. 393. So my initial temperature is 393 Kelvin. What is the new temperature? So I want to find out T2. In Celsius, you have to remember they want the answer in Celsius. If the volume is increased to 36 liters, so V2 is 36 liters. So now I can plug my numbers into my main equation. V1 is 13. T1 is 393 equal to V2, which is 36, over T2, which is unknown, so I will leave it as T2. Now I have to cross multiply, so 393 times 36 is equal to, cross multiply, 13 times T2. So now all we have left to do here is do the math, so 393 times 36 is 14, 14, 8. 14, 14, 8 equal to 13 T2. I have to divide both sides by 13 if I want to get T2 by itself. So this divided by, oh my god, I keep doing that, 14, 14, 8. Divided by 13 is equal to 1088.31 approximately is equal to T2. Now, remember, this is solving for Kelvin. That is a unit that we started. So T2 is 1088.31 Kelvin. But the question is asking for Celsius. So you have to convert this back into Celsius. And you use the same equation. Degrees Celsius plus 273 is equal to Kelvin. If you are solving for degrees Celsius, you leave that as degrees Celsius. Plus 273 is equal to Kelvin, which we said it was 1088.31. If I want to get Celsius by itself, I have to subtract 273 from both sides. And now I go to my calculator again. 1088.31 minus 273 is approximately 815.31. So degrees Celsius is equal to 815.31. My final answer being 815.31 degrees Celsius. Alrighty, next one. What happens to volume if I increase the temperature? What you have to remember is that variables that are one on top of the other have a direct relationship. So what that means is that if my temperature increases, my volume increases. If my temperature decreases, my volume decreases. So this is a direct relationship. They will do the exact same thing. What happens to volume if I increase the temperature? If I increase the temperature, my volume is going to increase. Because my volume increases, this means that I have more space. So the next part of this question is, how do the particles react? Well, my particles have more space. If they have more space to move around, it is less likely that they are going to bump into each other. So less collisions. Because they have more space and they're not colliding with each other as much, this also means that my pressure is going to decrease.